16. If you're allowed to use a calculator, you can do that or multiply by hand. That's 256. So that's
Okay.
not a big deal, right?
Mhm.
Now you could be asked to do the square of, for example, a fraction like 9/10. What is 9/10 squared? This means 9/10 times 9/10, which
Okay.
is 81/100.
Hmm. Okay.
Okay. So what we're talking about today, and this is, you know, we'll summarize here and then I'll have you try a couple of problems here, is square roots versus squares. So square roots are this symbol, squares are to the power of 2.
Okay.
It's all about the language.
Okay.
So
Yeah.
let's take a moment here just to look at these, make sure you've got these, you know, mental images down. If I ask you for the square root of a number or the square of a number, can you adequately, you know, apply the right rule there? All right. So is
Yes.
this okay?
Yes.
All right, so let's have you try one here. What is the square root of 25? What is 5 squared?
That would be 5, and that would be 25.
25, very good. What, now let me do it verbally here. What is the square of 11? Which one would that be? Or what would that be? Is
That
it
would be 121. Oh, that would. Oh, my bad. I thought you were asking me to solve a problem. There would be
no,
the
no, I am.
one on the right.
I am, and you did it. It is 121. Very good.
Okay.
Very good. Okay. So I believe you understand that. So now let's try some more difficult ones. So let's say the problem said to square -3/4. Okay. Square means to take whatever you're given and multiply it by itself.
Okay.
Okay, so that's what this means. So it's -3/4 times -3/4. What does that become?
Be -9/16.
So two negatives, though, they make a positive.
Oh yeah.
-3 times -3 becomes +9, and the bottom is 16.
16. Okay.
I want you to square 8/17 for me, please.
0/17. Okay. It would be okay, it would be 64/289.
Yes, very good. Excellent. Okay. Now we're going to switch to variables, okay?
Okay.
Because you can both square and square root variable expressions. Okay, so let's look at just a variable. So let's say I wanted you to take x to the 5th and then square it. Okay. So there are exponent properties here for this. And the exponent property here is that when you have an exponent to an exponent, you multiply the exponents. What would that become?
X 10.
10. Very good. Now let's say you have more than one variable and you're squaring it. You apply that exponent to both of these exponents here.
Okay.
So that would become a to the 4th, b to the 6th. So notice you're multiplying the exponents each time.
Okay.
Now let's say I throw in a number, like let's say it's 15x to the 4th squared. There's really a 1 above the 15 that's not written. It's really 15 to the power of 1. And just like in the previous problem, you apply that exponent to both. So it's 15 squared x to the power of 8.
Okay.
Now 15 squared, you can calculate, like you can get a number out of that. So you do want to continue reducing your 225x to the 8th.
Mhm.
Okay, so I want to give you some, I want to have you practice a couple of these, but any questions on this so far? Exponent to exponent, you multiply. If there's more than one, you apply it to both. If it's a number, you still apply it.
No, it seems fine.
Okay, so I'm going to clear the screen here, give you some problems to try. Y to the fourth, Z to the seventh squared.
That would be y8 and then z to the 28th.
You're
Right?
multiplying. You're
No, 14.
14. Good.
Right there.
Very good. How about 5x y to the third squared?
It would be 5x squared to, wait, it would be 5 squared to x squared to y6.
Good. Anything else you want to do here?
Oh, like finish the problem?
Yeah, I mean, like, there's a little bit more to do here. I would give you maybe a small deduction if I were grading this.
I would say multiply the 5 and the x since they're the same variable.
5 to the power of 2 can be reduced.
Okay.
What does that become?
Actually don't know.
So 5 times 5 or 5 squared?
5 times 5 is 25.
It's 25. So 25 x squared y to the power of 6.
Oh, okay. That makes sense. Okay.
Let me know when you get that down. Do another one here.
Okay.
All right, so let's try another one here. Let's go 2x squared y to the 3/2 power squared.
That would be 2, I guess 2 to the squared,
Good,
x to the 4th, and
good.
then y to the 6/4.
So you remember when it's an exponent to an exponent, you're multiplying.
Mhm.
So I'm really asking you, what is 3/2 times 2 or 2/1?
Okay, so that would be 6/2.
Which is,
It would be y 6/2.
does that reduce?
Yes, that would be 3 over
It is
2
3.
or just 3.
That's 3.
Okay, and then it would be, to finish the problem, 4, I think, yeah, 4, and then x of 4, and then y cubed.
Good, very good. Okay, so a little more information for you to be able to do some other problems here, but any questions on this? Do you have this written down?
Uh, three, 4, okay. Okay, I have everything down.
Got it.
Mhm.
Okay. All right, so we've got so a new problem here, new type of problem to look at here is, let's say it's something like this, like a to the 5th over b to the 7th to the power of 2.
Okay.
Okay, so
Now,
again, this means that you apply the 2 to both exponents. So it'd be a to the 10th over b to the 14th. Yes.
Okay.
Okay. Now I've been using 2 a lot, but we can actually use any number, but so just keep that in mind. Like it doesn't just have to be a 2.
Okay.
Like let's say it's x y to the 10th z to the 4 all to the power of 3. You're using that 3 and applying it to each of the exponents. So it'd be x cubed y to the 30th z to the power of 12.
Not too hard. Okay.
Is that okay? Is that clear?
Mhm.
All right, very good. Now let's do one with some numbers in it. So let's say it's like 3/4 xy squared to the power of 2. Okay. So this means that it's 3 squared. You're squaring each of them. X squared, 4 squared, y to the 4th.
Yeah.
Is that okay? So if that's clear, you then simplify. So you've got 3 squared, that's 9. 4 squared, that's 16. Y to the power of 4.
Okay. Okay.
All right, so let's have you try a couple here. See where you're at with your understanding. So let's say it's 5x over 2 y to the 8th squared.
That would be 5 squared, 5 squared x squared over 2 squared and y 16.
Okay, keep going.
And then that would be 10, then x squared over 4 and y 16. If I did that right.
25x squared
25.
4y to the 16. Okay.
Okay.
Now, what do you think happens if we put a -3 in the top? And I'll just keep it simple. Let's say it's a to the power of 5. What do you think happens when you square that -3?
It would just stay negative. It would be like, it would be -9.
Okay, so that's why I'm asking here. So here's another way to look at what we have written. It's -3a to the 5th times -3a to the 5th. Like when it's squared or to any power, it's this thing times itself.
Okay.
Okay. Now what is -3 times -3?
9.
9. So it's 9a to the 10th here. So the way to look at it when there's a negative is treat it like it's -3 in parentheses squared. And then just like you've been doing, a to the 10th.
Mhm.
Like 5 times 2. Okay, so if it's negative, treat it like it's squared. That becomes 9a to the 10th there.
Okay.
Is that okay?
Mhm.
Okay, let's try a couple more. Let's say it's -5 x to the 5th over y cubed to the power of 2. Go ahead and simplify this for me, please.
So- Okay, it would be 10
Wait,
x.
hang on. How did you come up with 10?
Oh, it would be 25.
Yes,
You keep-
-5.
yeah.
That's why we're doing it. It's because you're used to just multiplying, right? And you think, okay, I'll just multiply that. But that's why we're doing a bunch of examples, so you rid yourself of that bad habit. I don't know how else to express it here.
So it would be just in parentheses 5, -5 and a 2, then 10, x10, and then y6.
Okay, keep going. Keep going. You're almost there.
Then it would be 10 right? 10. And then, or would it
You're
be
multiplying,
25?
you're
Would
multiplying
be
negative,
25.
yeah, -5 times -5.
25, 10x
X to the
over
10,
x to the 10th, and then y 6.
y to the 6. Good, good.
Oh, that was tough.
Yeah, that's why we're doing these. They're just a little weird, a little wonky, want to make sure you've got them down here. Before we go to hard, there's more difficult problems you'll be seeing, but these are, gotta get the base stuff down.
Okay.
All right, so let me give you another one kind of like this. Let me know when you're ready for it.
Okay. I have everything written down.
All right, so let's go a squared b cubed over -3c to the 5th, all squared like that. So go ahead and work this out. Give me your final answer.
Okay, so it would be a to the 4th power, b to the 6th power, then -3 to the 2nd power, and then c to the 10th power.
Yes, now very, very important here is to, if you didn't write it the way I wrote it, which is in parentheses, you may not get the right result. So treat those negatives like they're in parentheses.
Okay. All right. And then that'd be okay, so then it would be a to the 4th power, b to the 6th power, then 9, and then c to the 10th power.
Very good. All right, let's do one more before we switch to square roots here. And let me know when you're ready for that.
Okay.
All right, -9x to the 1/2 over 4y to the 3/2 all squared.
Okay. Yeah, here it is. Yeah. Why is something? Okay. Third. So I have in parentheses -9 squared, and I don't know what would be for x.
So, so
Uh,
you're multiplying 1/2 times 2. 1/2 times 2. You can write 2 as 2 over 1.
Oh, okay. So 1, 2, 2. So that would just be 2. I
Over
think
2 over what's on the
2 over
bottom.
2.
Okay, and what does that reduce to?
I would say 2.
2 divided by 2. So you have
0.
Nope, not 0, not 0. Think of
Not 0.
division as a sharing problem. Okay. You have 2 pieces of candy and 2 friends. How many pieces of candy did each friend get?
2 friends, 2 pieces of candy, 1.
1. 2 divided by 2 is 1 because they're the same on the top and bottom. So it's x to the power of 1.
And then I have for 4 squared, and then y cubed.
Yes. Very good. Okay, so you gotta square those two numbers.
And this would be would be 18.
You're not
Y.
multiplying, not you're squaring. Squaring means multiplying it times itself. -9 times -9.
Wouldn't it? Oh, there we go. 9 times 9. 81. Is that wrong?
81. Okay, so 81 x and then 4 squared or 4 times 4.
4 squared and then y cubed.
And what is 4 squared?
Oh, that's 16.
16. Yeah.
Here. All right. Everything written down.
Okay, so take just 30 seconds here. We're doing a lot of problems here. Just relax. Clear the mind. We'll jump into square roots here shortly.
Okay, I'm ready.
All right. So let's start with some things that Let's go back to square roots. What is the square root of 100?
10.
It is 10. Now I'm going to give you some problems and I want you to tell me the pattern. The square root of 100x to the fourth is 10x squared. The square root of 100x to the 12th is 10x to the sixth. The square root of 100x to the 50 is 10x to the 25. Can you tell me the pattern here? Tell me what you see. Like, how am I going from the thing on the left to the thing on the right?
That's a good question. A bit confused.
So do you see that these all have a square root of 100 in them?
Mm-hmm.
And that's where the 10 comes from. Do you kind of agree with that?
Yes.
Okay, so try to think of a rule for going from x to the fourth to x squared. Basically, how do you go from 4 to 2? What's a possible rule for that?
Subtract by 2.
Subtract by 2. That's totally reasonable. Now, let's look at the next one here. If you take 12 and subtract 2, do you get 6?
No.
So it can't be 4 minus 2. So what's another rule? What's another way to go from 4 to 2?
Division.
Division. 4 divided by what?
4 divided by 2.
2. Now, is it 2 because of this 2, or is it just 2 because that works? 4 divided by 2 gets you to 2.
I would say because it works.
Okay. So is 12 divided by 2 6?
Yes.
Now let's look at the last one here. Is 50 divided by 2 25?
Yes.
It is. So that's interesting. You take the exponent and you cut it in half. You take the
Okay.
exponent and cut it in half. You take the exponent and cut it in half. Do you see that?
Uh-huh. So what would this be?
So
Okay.
just hang on. Just let that sink in that you can take the exponent and cut it in half.
Write this down. Okay.
Got it? Okay, so let's try a new problem here. What is the square root of 49?
Oof. Mm. What would be square root of 49? 24.5.
You keep in this, I mean, there's a common thing. You're not cutting this in half. You are
Okay.
taking the square root. You're finding two numbers that multiply together to get 49.
Okay. 7 times 7.
Okay, so the square root of 49 is 7.
Okay.
The square root of 49 x to the 8th is 7x to the 4th. Now, the distinction here is that when it's an exponent, you do cut it in half.
Okay.
But when it's a number, you literally take the square root of that number.
Mhm.
Is that okay?
Yeah.
All right, let's try another one here. How about square root of 49 x to the 18th? And let me add another letter in here, y to the 10th. What do you think that becomes?
7 to 7, then x to the 9th power, then y to the 5th.
You got it. So notice the rule applies. Doesn't matter how many x variables you have, you just keep cutting them in half. Okay,
Mhm.
is that all right?
I'm just gonna write this down. Okay.
All right, you got that down?
Mhm.
Okay, now some problems for you to try. What is the square root of 4x to the 12th? Give me your final answer for this.
It would be 2x to the 6th power.
Good. Square root of 36 x to the 40th y to the power of 4.
That would be would be 6 to the x to the 20th power, then y to the 2nd power.
Good. Very good. All right, let's try another one here. How about the square root of 400 x to the 1.2 power y to the 3.6 power?
Okay. Mm. Okay. Oof. So it would be 40.
Nope, try again, try again, try again.
Oh,
Square root of 400. So if it's 40, that means 40 times 40 equals 400. Are you allowed to use a calculator in this class? I can't remember. That's why I'm
I
asking.
am.
Okay,
Just trying
please,
to find.
I'm not anti-calculator, and if you need a, I might as well just drop it in the chat there. I always like the Desmos Scientific when I'm on lessons here because it kind of you enter it, and I threw that in the chat, the link to that. It's very intuitive. You sort of enter it the way you write it.
Okay. Let's see. What would be? Hmm. Oh, to the 8 and 50. That's what I got to 400. So,
Okay, so just to be clear, I mean, you can go right to the calculator and type in the square root of 400.
oh, okay.
Like this is, I'm not trying to give you any sort of mysteries here or be deceptive. It's just
20.
literally, yes. Okay, so that's 20. Now let's review here. How did you go from 40 to 20 in the previous problem, or 4 to 2 in the
You
previous?
divided by 2.
Right. So these exponents you will be dividing by 2.
Mhm. And I have, let's see, x would be x 0.6,
Good.
and then y 1.8.
Very good. So the trick here, or the challenge here, is that as soon as as soon as you think, oh, I got it, I feel really good about this, I just change the problem, modify it slightly, and it's very a little bit different. So we're going to do that now. We're going to look at a fraction. So we're going to take the square root of 144 x to the 10th over 25 y to the 4th. Okay. So it's kind of the same. I mean, and in the sense that you're going to do the same thing we've been doing. One little modification here is you take the square root of the top and the square root of the bottom. So you basically turn it into 2 problems and combine the results. So can you do that for me, please?
That would be 12 and 5. So
X to the
12
fifth.
and x to the 5th, and then 5 and then y squared.
Good. Like that. Great. Okay, so go ahead and get that down. We'll do another problem like this.
Okay.
All right, so here's another one for you to try. Square root of what have we not done in a while? Let's go 49 x to the 8th, and then we'll go on the bottom here. Let's go 16 a to the 70th power.
Be- so- Okay, so it would be 7,
Okay.
7 and 8 to the 4th power. That would be 4. 2 and 8 would be 8 to the, what was this? To 35th power.
35th power. Good. Okay. Great. So we've done a number of problems today that are in your problem sets here. There's
Oh,
a few
really?
other little ones that we can do, but I'm just going to kind of throw some mixed review at you and see where you stand here. So just as a reminder, if I ask you to square, that means power of 2. Square root means square root, the symbol here. Is that okay?
Mm-hmm.
All right. So I want you to take the square root of 25 over 16. And just give me your final answer for this one.
Would be 5 over 4.
Very good. All right, excellent. Okay, I want you to square 0.05. 0.05 squared.
Yes. That would be 0.0025.
Yes. Very good. All right, I want you to square -5/12.
Uh, okay. Let me see here. Square -5/12.
Square. What does the word square mean?
Oh, that would be times, so -5 times 5, that would be 25. Yeah, would be 25/144.
Very good. You're taking -5/12 and multiplying it by -5/12.
Mhm.
Very good. Okay. What is the square root of 9x to the 18th power?
9. It would be 3 and x to the 9th
Yeah.
power.
Yeah. Very good. Very good.
This is helpful.
Okay. All right.
Okay.
So we need to review a couple of exceptions.
Uh-huh.
Before we do that, though, can you tell me what is the square root of 16?
16 over 4.
It is 4. Here's an exception, the square root of -16. Right now, we're just going to call this unknown.
I remember
Okay.
something like this, yeah.
Yeah, it's actually, we're going to say not real, meaning
Ah,
that it's defined in the complex domain.
I
But
remember something, yeah, something my teacher was saying about these numbers that are
yes,
unknown are not real. So
right. So you have to be careful here. Like let's look at another one. Let's say it's the square root of -9/25. Even though you can write the square root of -9 and the square root of 25, this is also unknown at this point for you.
mhm.
All right. So any questions on that?
No.
Great. So in the last little bit of time we've got, we're going to talk about cubes and cube roots. We kind of alluded to
Okay.
this earlier, but just like squares and square roots, you can take the cube or cube power of 3 each for every number. So this literally means 1 times 1 times 1, which is 1. 2 cubed is 2 times 2 times 2, which is 2.
8, 2.
I'm sorry,
Okay.
8, not 2. 3 cubed is same thing, 3 times 3 times 3, which is 27. Notice the numbers are growing very rapidly. 4 cubed is 64. 5 cubed is 125. And these go on forever.
I have a big little table here in my book of 1 through 10 of square, cube, integer, and square again, I guess.
Right. So you want to memorize these. Now, you might ask me, why would I want to memorize them? And the answer is they help you to do the problems faster. It's not necessary to memorize them, but it will speed up the time that it takes to do these problems. And so
Uh-huh.
that would be the reason too. Now, very, very similarly, we can take the cube root of these numbers. The cube root of 1 is asking, it's literally asking, what number do you multiply by itself 3 times to get the number inside here? And that is 1. The cube root of 8 is 2. That means you take 2 and multiply by itself, 2 times 2 times 2 to get 8.
So multiply 3 numbers that would equal to 8.
But they have to be the same.
That to be the same. Okay.
cube root of 27 is 3. 27 is 3 times 3 times 3.
Uh-huh.
Okay. And then the cube root of 64 is 4, because 4 times 4 times 4.
Okay.
Right. So just to kind of, maybe this is already in your book there, but what is the cube root of 512? What number times itself 3 times gets you to 512?
8.
That is 8. Yeah. Okay. Now what's interesting is that while square roots have an exception here, cube roots do not.
Okay.
And you're like, what do you mean by that? Well, the cube root of 8 is 2. The cube root of -8 is -2. It's like, why does that work? You know what? I mean, obviously 2 times 2 times 2 is 8. Is -2 times -2 times -2 equal to -8?
Yes.
It is. Okay. How about the cube root of 64? We know that that's 4. Is the cube root of -64 equal to -4?
Yes.
Yes, it is. Okay. So problem for you, or one, you might even have it there. What's the cube root of -729?
So be 9. -9.
-9. My screen just glitched there. Huh, that's weird.
Oh, there you go.
I don't know why that's happening. Okay. All right. Let's do one more here. How about the cube root of -343?
It would be -7.
-7. Yeah. Good. So the challenge here is like, if I ask you for the square root of 1, you know that that's 1. And the cube root of 1 is 1.
Okay.
But the square root of -1 is unknown. But the cube root of -1 is -1.
1.
And if you look at each of these, they all they work. 1 times 1 is 1. 1 times 1 times 1 is 1. -1 times -1 times -1 is -1. But there is no number times itself that gets you to -1.
Mhm.
Okay, and that's where you got to be, very careful here. So like, again, like the square root of 4 is 2. The cube root of 8 is 2, but the square root of -4 is unknown. But the cube root of -8 is -2.
Okay.
So just, some of these work, some don't. That's the challenge here. That's probably where you're going on
Yeah.
that. All right. Wow. So great lesson today.